Nomenclature. Alkenes, alkynes. They're really similar. If you know alkenes or alkanes, then alkenes and alkynes become really easy. They just have a different ending. People are already coming out of lunch. All right, we use the term "ene" for the ending of double bonds, E-N-E, and "eine" for the ending of triple bonds. So what you do is you find the longest chain, just like you did last time, except this is the longest chain with the double or the triple bond. And then you give the lowest number possible of the first carbon, and then you branch just like you did before. If there's more than one double or triple bond, you use di and tri. So like diene would be 2 double bonds, and triene would be 3 double bonds. I want to point out to you that there's a lot of common names that are still used, like ethylene. For whatever reason, it won't go away, even though the IUPAC name is ethene. It used to be like, and here's another one, acetylene, and the IUPAC name is ethine. Yep.
If there's more than one triple bond, you have to use like, you have to spell diene, like a Y-N-E.
Yeah, like diene. Yeah.
Okay.
Yeah, I guess it would be pronounced kind of the same way, wouldn't it? Okay, so here's some examples. So you have 1 butene, right? 1, 2, 3, 4 carbons, but the double bond is located on carbon number 1. Whereas here's 2 butene, 1, 2, 3, 4 carbons, but the double bond is located on carbon number 2. Here's 1, 2 hexene, because there's 6 carbons and there's the double bond. And this one is also a hexene. This is an example of make sure you have the longest chain with the double bond. It may not be the longest chain. So when you look at this, like this looks like the longest chain here, but this is what you're going to use for the longest chain. 1, 2, 3, 4, 5, 6. And then hanging off up here is going to be your propyl. Okay? Got it? Okay. All right. Notice the way these are written. They kind of look like they are like kind of like squatting out to the side. You'll find why that is in a minute, but see if you can name these ones. Like think about the names of these guys. What's the first one? Yeah. One, no, not hept. 1 pentene. And then this one is what? 2 hexene. And then this one, 3 octine with a Y-N-E. 3 octine.
Wait, what about?
Oh, sorry. Yeah, lies. Forgot about that. 7.
Yeah.
7 methyl. 3 octine.
And for the second one,
Oh.
is it
Wait,
2
what do
methyl,
you do
2
with the other
hexane?
one? Yeah. Isn't it supposed to be a
For the hexane.
Wait, no, it is. Wait, for the hexane.
For the hexene, oh, there is a methyl there too. Sorry, I was not paying attention to anything. You can see how distracted I am about my life's happenings here. All right, let's move this 2 hexene over because there is a methyl group here. So we have a 2 methyl 2 hexene. Yay. Yep.
Wouldn't the bottom one be like? Wouldn't the 7 actually be a 2, and then the?
No, great question. It's because Now, in this case, you want to give the triple bond a lower number. It takes precedence over where it branches. So she asked, wouldn't that be a 2-methyl, but it's going to be a 7-methyl. All right, much better. Okay, so name this compound. Step 1, find the longest chain. 1, 2, 3, 4, 5. Then you want to number it in the direction that gives 1, 2, 3, 4, 5. You want to give that triple bond the lowest number. And then you've got a methyl group here off of number 4. So you have a 4-methyl, 2 pentyne, pentyne.
Wait, why is it 2 and not 1? How do you know?
Oh, 1. Oh my gosh, thanks guys.
Extra credit? Yeah.
Millions of extra credits. I'm having a rough day. Billions of extra credits all over. Yes, 1. 1, 1, 1. All right. Listen, this is something I can't screw up at least. Ah, it's good, isn't it? I'm
Good. Pretty nifty.
dying. Oh, goodness.
Really good.
So don't forget, when you're dying, you need twice as many. So again, we'll count carbons. 1, 2, 3, 4, 5, 6. 1, 2 would give us the double bond. So in this case, we're gonna also try to keep the bromine as low as possible. So 1, 2, 3, 4, 5, 6. So that the bromine also, because you see there how the double bond could be also 2. So you get a 2 bromo, 2, 4, oops, sorry, yeah, no, hexadiene. Hexadiene. I'm dying. I'm dying.
Your son is dying.
Yes, the moment he's dying. Still getting blown up. All right, conformers versus isomers. Remember, a conformer is the same molecule, temporary different shapes due to rotation. Isomers are completely different, but with the same molecular formula. Well, now we're going to differentiate. The first thing that we talked about, these were called structural isomers. All right, this is where I actually, I pulled off this carbon, I pulled it off of here and I stuck it down here. That's a structural isomer. It's totally different arrangement, different properties. Well, here's a new thing. This is called a geometric isomer. Woo! Geometric isomers are going to tell us whether the molecule is cis, which means it's on the same side, or trans, which means it's on a different side. And that's why those molecules were drawn the way they were earlier. And this is because you cannot rotate around a double bond. When you try to rotate around that, it doesn't work. So they're not the same as structural isomers, but they are very much the same as like having different chemical properties. So here's an example right here. Here's chlorine is down here and up here. So that's trans 1,2-dichloroethene. And this, the chlorine is on the same side. So it's cis 1,2-dichloroethene. Got it?
Yep.
Okay, let's look at some more. Here's butene. Notice there's no substituents. It's just a butene. So here's 1 2, 3, 4 carbons. 1, 2, 3, 4 carbons. The one on the left, this is cis 2-butene, and here's a trans 2-butene. All right, here's cis 1,2-dichloroethene and trans 1,2-dichloroethene. Differences in these are going to be boiling points, melting points, and they're going to exist differently. So this one is less likely to exist, this one right here, because we know because of Vesper, they're going to try to spread out the best that they possibly can. So the trans is going to exist more than the cis. The trans is going to cancel each other out better due to its symmetry. Remember, cis-trans can only happen if you have, something attached to the other side of the double bond. Like this can't have cis-trans isomerism because this carbon is attached to the same thing. So it doesn't matter. These are just exactly the same as each other. These are the same molecule, even though they seem like they're flipped. It doesn't matter because this carbon is attached to an identical group. And if you want to read about this, the chemistry of fission exists because of cis-trans isomerism. Okay, you're good. Go to lunch.
Thanks.
Yup, thank you.